Okay, so today we're going to be starting Unit 5. What I did is I kind of pre-filled in the definitions here, and I'll scan this page in. So you're going to want to pause and fill in your definitions before we get started, or you can kind of go along with, and as I talk about the first one, fill that in. But you may need to have that other document up just to kind of view what I've filled in here. So this unit's all about polynomials. A polynomial is a collection of variables, exponents, and operations. So for example, 3x minus 4x squared plus 7. So I have variables, I have exponents, and operations, meaning connected with addition, subtraction, multiplication, or division. So here's my example of a polynomial. Now within this, we need to know a few things. So first of all, a simplified polynomial has all the parentheses cleared and the like terms have been combined. So this would be simplified because I don't have any like terms here. Right, this x squared could only be combined with other x squareds. This x could only be combined with other x's. And this constant term could only be combined with other constant terms. And I have no parentheses, so this would be good to go in terms of simplification. Each of these is called a term. So I'm going to give actually a separate example. 11x minus 2x squared plus 3x to the fourth, subtract 1. So when I look at this polynomial, each individual term, okay, these would each be a term in the polynomial. Those are terms, and they're connected by addition and subtraction. The degree of the polynomial is the exponent. This is an exponent of 1. This would be a degree, I said polynomial, but I was talking about degree of a term. This is a degree 1. This is a degree 2. This is a degree 4 term. And this would be a degree 0 term. There's no exponent at all here. There's no variable term at all here. Okay, so each of my terms can be classified by degree. We also have coefficients. So for example, 11 is a coefficient, which is just the number that's in front of our variable term. And a constant, so here -1 is our constant, is the term that has no variables. Okay, it's a constant term, there's no x connected to it. And last, the degree of the polynomial is determined by the largest exponent. So this polynomial would be a degree 4 polynomial because this is the largest exponent in my polynomial. And along with this, we have something called the leading coefficient. And so coefficient, number in front of our terms, the leading coefficient is the number attached to the largest degree term. So leading coefficient doesn't necessarily mean if it's written in standard form, which we're going to talk about in a minute, it would be the first coefficient. But it doesn't necessarily mean the leading coefficient if it's out of order. My leading coefficient here would be 3 because that's the coefficient attached to the largest degree term. Now, we are going to get in the habit of writing our polynomials in what's called standard form. So standard form of a polynomial means that when I write that polynomial, it's going in order from largest degree to smallest degree. So if I were to take my example that I wrote up above and rewrite it in standard form, I would have 3x to the fourth as my largest degree, followed by -2x squared, followed by 11x, followed by my constant term. And now this is in order from largest degree to smallest degree. Again, this is 3 would be my leading coefficient, because it is the number attached to the largest exponent. This would be the degree of the polynomial, because it is the largest degree in this polynomial. And then this, just one more time to emphasize, is called our constant term, a term without our variable. So as we add, subtract, multiply, and divide these polynomials, we want to make sure that our final answer is always written in standard form. Before we get to doing operations with polynomials, we're going to work on some vocabulary. So we want to be able to talk more specific than just saying polynomial. Now, polynomial means, or poly means many, so we're talking about many terms there. But if we just have one term, then we can call it a monomial. For example, if we're just looking at 3x squared, single term, this is a monomial. If I have two terms, right, like two wheels on a bicycle, binomial. So maybe I have 3x squared plus 7. Two terms, that's a binomial. And you may have guessed that 3 terms is our trinomial. So maybe I have 3x squared plus 2x plus 7. There's a trinomial. And we look at trinomials a lot, actually. In future units, we're going to talk about factoring a trinomial. And so these words, these vocabulary words come up in future units, and it's good to know what does binomial mean, or what does it mean when we say factoring a trinomial. If it's anything 4 or more terms, we'll just call it a polynomial, meaning many. We also can classify our polynomials by degree. So if I have a degree 0, that means I have no variable term. So for example, just 5. That's a degree 0 polynomial. Now, this is just a constant term, and that's what we call it, a constant. If we have a polynomial that's degree 1, that means the largest exponent value in that polynomial is 1. I have something like 3x plus 2. Largest degree is 1. These polynomials are linear. Just like this would create a line if I graphed it. If I have my largest degree is 2, so maybe I have 3x squared plus 7x minus 1. This polynomial, my largest degree is 2. That's a quadratic. I spend a lot of time with quadratics in the second semester of this course. If my largest degree is 3, maybe I have x cubed plus 1. That's a cubic. And I'll scan in this page with vocabulary as well, in case you need to fill in any parts. If my largest degree is 4, and so just to point out, it doesn't have to necessarily be in order. Maybe I have that polynomial. Well, that polynomial still is a degree 4, because that's the largest exponent I have, and that's called a quartic. And if my largest degree is 5, maybe I have x to the 5th plus 7x cubed. Largest degree is 5, we call that a quintic polynomial. And so what we're going to do is we're going to classify our polynomial in a few different ways. So for example, my first polynomial, there's no exponent here. This is a degree 0, which means it's a constant. And there's only, classified by term numbers, there's only one term, which is a monomial. The degree of this polynomial is 1, largest exponent is 1, which means it's linear, single term, monomial. So I could label these, I could describe these and say, well, this is a constant monomial, this is a linear monomial. Both talking about the degree and how many terms I have. Now the next example, also largest exponent is a 1, so it's still linear, but now we have a linear with 2 terms, we call that a binomial. Linear monomial, linear binomial. Next example, largest exponent is a 2, which means it's a quadratic. And I have 3 terms, trinomial. Largest exponent is a 3. It's a cubic. I have 2 terms. That's a binomial. My largest exponent is a 4. That's a quartic. And I have 4 terms, so we'll just call that a polynomial. Okay, so labeling both using the degree and the number of terms. So each label is, I don't really need this. This was just to kind of help me get here. Okay, each one of these polynomials I'm using 2 words to describe: cubic, binomial, quadratic, trinomial. So now what I'd like you to do is go ahead and complete A, B, and C and classify by both degree and number of terms, and then continue the video and see how you do. I should actually say it goes on to the next page. So you want to do A through F, classifying each of those polynomials using 2 words, one for degree and one for number of terms. Okay, so let's just go over these real quick. First, we have degree 1, so linear binomial. Degree 2, which is a quadratic, 2 terms, binomial. Cubic, trinomial. And I'll let you kind of self-check the 3 on the back. So now we're going to transition into doing some operations with these polynomials, starting with addition, subtraction. Now, when we add and subtract polynomials, we're really just combining like terms. I mean, truly, that's all we're really doing. There's kind of 2 ways that you can organize your work, and it's going to just depend on who you are and how you like to kind of organize work in general, in terms of how you may choose to arrange these things. So the first way we're going to look at this is organizing our terms vertically, one on top of the other. So if I take this first example, one thing that's going to be important is that we want to write our answers in standard form. So it says that right here, but I just want to point out that our answer should be in standard form, which means largest exponent to smallest. So I'm going to rewrite this problem, and as I rewrite it, I'm going to write it in standard form. So this first polynomial would be negative 3x cubed plus 2x squared plus x, written in standard form, largest to smallest exponent. Our second polynomial would be, and watch how I do this, negative 4x cubed minus 6x plus 3, written in standard form. And so you can see what I did is I kind of left a gap here, and that's so that I can create columns essentially of like terms. And then I'm just going to add them together. I mean, really it's the same as this, 53 plus 19. And I have my ones column and my tens column. And I'm going to say, okay, 3 and 9 give me 12. Now I'll add my tens, gives me 7. It's the same idea in terms of that sort of vertical setup. That's what we've done here. So now I'll just combine like terms. So I all together for my x cubes, I have negative 7x cubed. I have 2x squared, negative 5x, and positive 3. And it's important that each term is connected with addition, subtraction. So sometimes students like lose the addition when I just have a positive number. Make sure that each term has addition, subtraction between it. And then because we've already organized our terms in standard form to add, our final answer is already in standard form here. So I'm going to do the same thing here, but now I'm adding 3 polynomials together. So I'm going to take the first polynomial and write it in standard form. So 5x cubed plus 2x squared, subtract x plus 7. So making sure I reorganize terms as I go. And then the second polynomial, I have 3x squared. I'm going to flip these around, right? So now negative 4x plus 7. And I can just go ahead and write the third polynomial underneath. I have negative x cubed, putting that in the same column with the other x cubed, plus 4x squared. And then I have negative 8, which is a constant. So by arranging it this way, I'm really grouping like terms as I go, adding these columns together, right? This is addition, giving me 4x cubed. Then I have, let's see, I can't tell if they're positive or negative the way I drew it in. So positive 4x, positive 3, positive 2. Okay, so all together I have 9x squared, negative 5x, negative 1 and negative 4. 7 and 7 giving me 14. take away 8, giving me 6. Okay, so just setting up some vertical addition, just like what we've done, adding and subtracting always, and combining those like terms, intentionally putting it in standard form as I go. Now the other way that we see addition is like this, right? If I have that 53 plus 19, and we just add horizontally across. So that's another option here, and I like to kind of color code when I do this. So I still think about standard form, and I just go through, and I say, okay, my largest exponent is x squared. So I have 2 here, and I'm adding 1 here. So that's going to give me 3x squared. And then for my x's, I have 1 here and 1 here, so I have 2x. And then for my constant terms, I have -5 and +6, which gives me 1 all together. And there's my polynomial. I've combined them. I just kind of went through and collected what I had, written my answer in standard form. I'm going to do the same thing here. So here, if I want standard form, my largest exponent is x to the 4th. So I have 1, and I have 10. So I don't need to write 11x to the 4th. And then my next largest exponent is, I have to get rid of that plus thing, is x cubed. So I have -5x cubed, and I don't have any others, so I'm just going to have -5x cubed here. And I don't see any x squareds, but I see 3x and -6x, so that's going to give me -3x all together. And -2 and -8, giving me -10 all together. And so you can really choose what method works best for you. I mean, as somebody who likes to organize, I like this top method because it's a little bit more organized. And you could easily kind of miss something here. But whatever way you prefer to add the polynomials is fine, as long as you're doing collecting things correctly and that you're writing your answer in standard form. Okay. Now, subtracting polynomials is essentially going to be the same procedure. The difference is that we are never going to actually subtract. We're always going to change to addition first and then add. Okay, so we're going to do exactly what we did up above, but instead we're going to rewrite the problem first. Meaning, instead of subtracting, really we want to distribute. And so the reason we do this is because that negative, that subtraction, is going to impact all 4 of these terms. So I'm going to distribute that negative through and rewrite it as addition, and it's going to flip all of these signs around. And I want to be really careful that I subtract each term, that each term gets that negative. So I start by changing this problem to an addition problem. So instead of subtracting this top polynomial, I will add this bottom polynomial. And sometimes I even go ahead and I just cross this out. So I'm no longer looking here. I've changed it to adding the opposites. And so again, with subtraction, now that I've changed it to addition, I can either do the vertical format. So 6x cubed, now I'm going to leave a little space for x squareds here, 5x, and -3. So you notice I just kind of intentionally left a gap in case I have an x squared term to add in. And my other polynomial, my revised one, is -2x cubed minus 4x squared. That's why I left that gap there, plus 3x minus 1. And I've collected things into standard form. Adding my columns gives me 4x cubed minus 4x squared plus 8x, subtract 4. Okay, so once I've changed it to addition, I'm really doing exactly what we did up above. Okay, but always, always change it to addition. If not, like 99% of the time, if you don't try to change it, you mess up a sign over here. So changing to addition, distributing that negative through, makes this adding positive 12x to the 4th, negative 3x cubed, positive x squared, and -10. Now, if I want to add vertically, I'm going to take my first polynomial here. So 16x to the 4th. I don't have any x cubes. I'm going to leave a little space there, -2x squared. I'm going to rearrange these and write -2x, then +31. And now I've changed it to addition, and I'm going to add this polynomial in, 12x to the 4th minus 3x cubed plus x squared, skipping a little over so that things are lined up. Okay, so notice I left a space there. That gave me a space for this cubed. I left a space there so that the constant terms are lined up. And then adding those together, I have 28x to the fourth minus 3x cubed minus 1x squared minus 2x plus 21. There's my addition. What we ended up doing was addition of our two polynomials. Now, just like addition, I could also horizontally combine these. But again, the important piece here is always change it. So distributing that negative is going to change all of my signs. Again, if you need to, cross that out so you're not even looking at it. And now, largest exponent to smallest, so starting with the x squareds, I have positive 6, negative 8, so altogether I have negative 2x squareds. I have 12 x's and 3 here, so I have 15x and 6 and negative 4, 2. On the next one, same idea. First, I'm going to rewrite this, distribute that negative through, change all of our signs. And if you have like in the homework or in problems down below, because I'm going to let you kind of do the problems, you won't down below, but in your homework, let me grab the homework real quick. If you have more than one, I just kind of want to show you that. I'll show you one of the homework problems in a minute. So again, you need to cross that off. Largest exponent being a cube, so I have 6, take away 11, so negative 5 x cubed. Then for my x's, I have negative 12x, and 1 gives me 2. So what I'd like you to do now is there's 6 problems attached here for you to try on your own. So I want you to go ahead and try those and then continue the video and check how you did. And then once we've checked our work, I'll do one of the homework problems with you just to show you what happens when we have both addition and subtraction in the same problem. Okay, so just kind of check yourself on how you did with these addition subtraction problems. Again, making sure you're changing subtraction to addition. And also check to see, did you write your answer in standard form? It should always be going from largest exponent to smallest. So check those things as well. So you may want to pause that there because I'm going to switch over to homework. So if you're still checking your work, pause and then continue. And I'm just going to do one homework problem. So on the homework, I want to look at number 6 and just point out. So on 6, I have 3 polynomials, or 2 binomials and a trinomial here. And I'm going to subtract here and add here. And so I just want to point out that this subtraction is only going to impact the parenthesis attached to it. So this means I'm adding negative x to the 4th plus 3x plus 5x cubed. So I'm going to change that middle term to addition. I wouldn't mean that I'd change here. Certainly wouldn't mean that I change here. And now I'm just collecting my like terms. So looks like I have an x to the 4th, so negative x to the 4th, that's my largest exponent. And then 8, 5 more, so, and 1 more here, so 14 x cubes. I don't see any x squareds. I see 3 plus 1 is 4, plus 4 more, giving me 8 x's. Okay, so same idea, but just knowing that that subtraction is only impacting, in terms of changing signs, the parenthesis directly after it. Okay. All right. So now we're done in terms of notes today, and tomorrow we'll do some warm up, and you'll be working on this homework to continue practicing this skill.